All right, looks like we're rolling. Sorry about the late start. Okay, so before we get started talking about Project One, does anyone have any questions from last time about the AWS stuff? Account word pair script is empty? Let me see.
Yeah, I don't want to get the notebook.
These are compliments from the or in your example. Yeah, that is helpful.
No, well, it's not mine. That's from a previous semester. Um, what we would need to do. That's the wrong one. It's in Spark SQL. This is empty. Oh, that's weird. Okay. I will go and push that up right now. That's empty too. Oh, that's strange. On moving it, but I may have been distracted and never actually moved it. So it's here right now, and I will move it right after class. Okay. Oops. Any other questions? All right, let's get started. Okay. So what we're going to be doing is we're going to be looking at the Wikipedia graph and the links between articles on the Wikipedia graph. As you know, Wikipedia is a directed graph, and so the links between vertices in this Wikipedia graph have a direction associated with them. So just because A links to B doesn't mean that B links to A. What I want to see is I want to see a list of pages that link to each other. So, for example, you might have the the Wikipedia article on the Arctic, and you might have the Wikipedia article on a polar bear. Now, the polar bear is a very famous species that lives in the Arctic, and so in the wildlife section of the Wikipedia article on Arctic, we might see a reference to polar bears somewhere. Wow, you're taking your sweet time. There we go. So there's a polar bear up here, and the article on the Arctic links to the article on the polar bear. Now, the polar bear article probably also links back to the Arctic. So these articles link to each other. And this is a pretty good indicator that they're conceptually related in some way. And this association between the two things is stronger because they link to each other. Because there are plenty of articles that link to other articles that don't link back. And this makes sense. Like a good example that I came across when I was looking for things to talk about today is Lord Kelvin was a British physicist, and apparently he really liked this compass. And this Wikipedia article provides a link to the concept of a compass. Now, you would not bring up this British physicist who studied thermodynamics in a conversation about a compass. But he owned a compass and he liked a compass. Whoop-de-doo. But I wouldn't say that a compass and Lord Kelvin are related, just because there happens to be a link from Lord Kelvin to the compass. But if there's a link, if there's a mutual link between these two articles, then that would show a stronger connection between those two concepts. And that's what we're going to look at with this assignment here. So you have access, you should have access to all of the data sets that you would need in order to calculate this set of pairs of articles that link to each other. So we have the articles, which is which contains the text of every Wikipedia article. You don't need this for this assignment, but it is there if you want to check it out, if you want to look at it. There's also the link target table, which takes which is a list of unique elements in the Wikipedia database that have links to them. Not strictly pages, but a bunch of other things too. And this is where we learn that the way Wikipedia has organized its data is strange. So you're going to have to do some joining on these tables in order to create a data set that we would actually want. So we have the link target table, we have the page table, which contains the page ID of all of the pages, along with the title. And we have the page links, which provides for every page, it gives us an ID of the link target that the page has a link to. Not the other pages, but the link target. And the link target can refer to a page or an image or a file or anything like that. And so you'll have to filter them out. And lastly, we have the redirect table, which is where, you know, if you've ever used Wikipedia and you click on a link, a lot of the time it'll take you to a page and then automatically redirect you to another page. And, you know, in the HTML at the top, it'll say, oh, we redirected you from this to this. There are a lot of Wikipedia articles that are just duplicates of each other. And so going to one article will just redirect you to the main article on that topic. And this database, the redirect database or the redirect table, provides all of the redirections in Wikipedia. Okay. So let's go through the details of what we want to do. We want a list of all of the pairs of articles that link to each other. So the example we went through earlier is the Arctic, which is a region in the northern part of the world, and polar bear have links to each other. Arctic links to polar bear, and polar bear links to Arctic. So that pair of articles would go in our expected data set. A counterexample to this would be, you know, Lord Kelvin and compass. The compass article does not contain a link to Lord Kelvin, but the Lord Kelvin article does contain a link to compass. That would not go in our result data set. So we only want pairs of articles that link to each other. So what I want from you, what I want your program to output at the end of its run is I want a single table with two columns. I want a page A column and a page B column. The values of these columns should be the IDs of the pages that are involved in the pair. And the page ID is just a number. Make sense so far? Cool. Okay. Now, you should not have repeat pairs in your data set. So sometimes an article will link to another article multiple times. So if an article links to another article multiple times, then I want you to just include that pair once. And that includes duplicate pairs where these things are flipped. Because, you know, saying that Arctic has a mutual link with polar bear is the same thing as saying polar bear has a mutual link with Arctic. So I should not see two rows, one Arctic polar bear and the other polar bear Arctic. I want one row. because we're basically taking the directed graph from Wikipedia and making an undirected graph of mutual links. So we don't need to duplicate our edges anymore. Because a reversed edge would mean the same thing in this case. So we should not have any repeat pairs in this data set. What you also need to do is you need to account for page redirects in your pairings. So if you have England, which links to Great Britain. Then you have United Kingdom over here. Great Britain redirects to United Kingdom. And then United Kingdom links to England. The pair that I want to see in your data set should be England. England, UK. Does that make sense? Cool. All right. So this project is worth 180 points. And the points are going to be broken down as follows. Is that actually total to 180? Did I totally botch the math? No, it's right. Okay. I'm going insane. Okay. So the first 40 points, I'm going to grade on code and submission quality. Code quality is very important, and I don't think we grade enough on code quality at Boise State. And given my past experiences teaching, I don't think I put enough weight into it. So code quality is very important. Make sure your submission is clean. Make sure it's readable. Please use things like consistent indentation, please. And make sure it's properly documented, and I know how to run your code when I read your documentation. The next 50 points just go to your basic construction of the pairs, and is that construction of the pairs correct? So, like, are you correctly, getting the pairs from the page links table and linking them to the link target table, and you're linking the link target table to the pages table. So you're going to have to chain multiple joins together in order to produce this data set. The other 50 points beyond that are you need to account for redirects and you need to make sure all of your pairs are unique. So if you do all that, you'll get the 100 points for correctness. And the next 40 points is performance. You need to make sure that your code from beginning to end runs in 75 minutes or less on a single R6GD instance. So I'm going to restrict the amount of hardware you're allowed to use. So it's because you shouldn't need more hardware than this to get it to run under 75 minutes, and also money. All right. So as for actually submitting the project, create a private Git repo to, for source control and to manage your project and everything. It must be private. Do not create a public Git repository, please. So when you're ready to submit it, invite me as a collaborator to the project so I can see it. If I see commits that were submitted past the due date, then I'm just going to roll back your project to the latest commit that was before the due date. Make sense? Okay. You're not allowed to submit a Jupyter notebook. I know that we've been working with Jupyter notebooks for our in-class examples the entire time we've been working here, and Jupyter notebooks are great for when you're actually working on the project, but when you submit it, don't use a Jupyter notebook. It should be a normal Python project. And we're going to go over how to submit that or how to run code on EMR without a Jupyter notebook today in class. But what you need to submit is when you submit a step in EMR, it needs to have an entry point file, which is the Python file that starts off your code running. And there's a zip file with the rest of your dependencies and the rest of your code that's going to be running. So you submit two things to Spark in order to start the code. What I'm also going to do is I'm going to supply an environment variable to you guys called page pairs output. And that is going to contain the S3 URI that you need to write all of your output to. Does that make sense? Because if you include an S3 URI to write to in your code that matches your account and not mine, I won't be able to see. So I need to be able to point you to output code to my account. And make sure it's in Parquet form when you write it out to this page pairs output path. Does that make sense to everybody? Questions on anything? Go ahead. That's what we're here for.
Okay. First, I don't plan on using them, but the commit past the due date, that doesn't include the dates, right?
No, so if you email me and you let me know that you want to use some of your late day coupons, then that's fine.
And then second, you said logistically, as long as we're not doing anything stupid with AWS, we're not gonna raise the yelling at us.
No, not really. So I put this in the guide to starting in EMR cluster, but we could actually go over that now. Restrict yourself to using only these instance types. So that's not big enough. Okay. C6GD, extra large, C6GD, 2 extra large, and then M6 and R6 for extra large and 2 extra large. So this will restrict you to using fairly small clusters. And in addition to restricting yourself to only using these types of instances, do not create a cluster with more than 4 nodes total, with more than 4 nodes in the core group. So you can have 1 primary node and 4 nodes in the core group, 4 worker nodes, but don't create more than that. So we want to control how much we're spending. So in the software settings, you can put, this configuration in. I did add one thing to the configuration that will just make it easier for you to use Spark interactively and to cache data, which is the idle executor timeout, which is basically if you leave it alone for a few minutes, it won't kill it because you're not using it. So I'll add that in. Okay, has anyone used this guide yet? Are there any questions on what you're supposed to do? Huh? Okay, yeah, that's fine. That's fine. Okay, I think that's it.
I think that is one for the I actually drink it. I need to go.
Okay.
One last question. Data source you provide, is there any place to like visually look at them?
You can view them through the AWS CLI, maybe. But not in the console, because the console will only display buckets that you own to you.
I was flying to the night. So
Okay.
this,
I mean, we can look at the AWS CLI. I'm going to show you how to set that up right now. Any other questions? And also, if you have questions about what exactly code and submission quality mean, feel free to come and talk to me. But for the most part, it's just common sense. Like, don't put unused variables in don't submit code with unused variables in it. Mostly just things that your IDE would warn you about. Oh, yes, the due date is up here. It is October 18th at 11:59 p.m. So you have a month. Cool. Cool. All right, let's get into the AWS CLI. This will be fun. All right. So in order to use the AWS CLI, you have to actually install it, which your mileage may vary depending on which system you're running. So this is Fedora Linux, so it's fairly easy. I just had it's good. Is that good? That took its sweet time to shrink. All right. So first you got to run AWS configure or so first thing you want to do is you want to go into your account in the console and click on security credentials. Okay. Now you're probably going to see a notification to set up multi-factor authentication, and I highly recommend that you do. So after you've set up multi-factor authentication, you need to, I'm not allowed to create an access key. Why am I not allowed to create an access key? Oh, is that the web page just acting weird? Yes, it is. Okay. So it's going to warn you when you try to create an access key that this goes against best practices because this is your root account and you're supposed to be using principal of least privilege and everything when you're creating new IAM roles and accessing AWS and stuff like that. This is not a class on AWS, so I don't care. I want to simplify your use of this infrastructure as much as humanly possible. So when you're working for a company, don't do this. They're probably not even going to let you do this. So it's maybe a moot point for me to tell you not to do this. But if you're working for a company and you need to configure, CLI access, don't do this. But I want to simplify things, so we're doing it anyway. Okay. So what you need to do is after you create the access key, you can call AWS configure, and it will give you, these series of prompts. And you should just put those in response to those prompts. You copy and paste, this access key over here, and then you reveal what the secret access key is, and you paste it in there too. And your default needs to be should be US West 2, the default region. We're not going to go outside of US West 2 in this class. So that's what it should be. And don't put anything for default format, and that should be it. So after that, you should have AWS CLI configured. And so you should be able to access AWS and run AWS commands from your terminal. So here's what that looks like. We can list out all of the buckets that are available to us with S3. And there are two of them. So for me, it's just the commons directory or the commons bucket. And then we can list everything that appears in commons. Let's see what happens when this is. Really? Oh, so it must not list out the prefixes. So this is part of what we covered in S3 earlier, is that since it's not a directory structure, the default is only to list things that appear directly in the prefix. So there's no non-folder object that appear, except for this, maybe? I don't even know what this is. Is this just a marker? But aside from this thing, there's nothing that appears in the root directory of this bucket. So we'd probably have to look somewhere in data sets, and then we'd see all of these gzip SQL files. So let's see if we can see anything in there. Look at that. Okay, so we see all of these gzip SQL files. What we don't see is the Shakespeare data set and some of the other Wikipedia stuff in here because those are other prefixes that have absolutely nothing to do with this data set's prefix over here, in spite of the fact that it looks like it's hierarchical. So this is a perfect example of the fact that S3 is not a hierarchical system because it's basically acting like these two things, Shakespeare and Wikipedia, aren't there. Wait, that's not true. So then why didn't it? Why didn't it list over here then? Oh, that's weird. Okay. So this changed. This is not what the AWS CLI used to do. What the AWS CLI used to do is it used to completely ignore everything in here that was not just an object. That's nice. So you can list everything with the CLI. Sometimes I like being wrong.
You can't like navigate down.
No, so there's no CD or anything like that. Because this is not a directory structure.
Or you have to like look over to already know, like this thing door. Like you would have had the ID like, oh, when you listed them here.
Yeah, and for some reason they appeared because the inner command is list objects. And these prefixes are not objects, which is interesting because I didn't think it would do that unless it's done something outside of what the S3 API normally offers. Let's look at the S3 voter API. Whoa. For general purpose bucket, doesn't return prefixes that are only. Okay. That's weird. Huh. Okay. So that's nice. It does list out the prefixes. So you can kind of list it hierarchically if you wanted to by just continuously expanding things. So if you wanted to list everything in my workspace, you can. There we go. And so it's just these 5 things that I showed you in the assignment write-up. Okay, now setting your credentials on AWS Configure also allows you to use the AWS API packages locally as well. And an example of how we would do this happens in, whoa, that is not what you're supposed to be doing, sir. Still? Could be in, so we have this script, which is starting an EMR cluster from Python. This is too small. Okay. I should also expand it a little bit. Okay. So this is the code I'm going to run pretty much to start the EMR cluster when I run your code. So what we're going to do is these are all the configurations I'm going to use. And these are the same configurations that you would normally use when you're running EMR interactively, except for this one, which is just the page pairs output, which is to supply that environment. You're gonna, thank you. Okay. All right. So over there is where you specify the configurations. Over here is where you specify the instance groups. So the first instance group is the primary node, and we pretty much always want this to be a C6G extra large type instance. That is the smallest instance type available to EMR. And the primary node basically doesn't do anything in EMR anyway, so you can just leave it as the smallest instance type and it won't make a difference. Because the only thing the primary node does is keep track of all of the other nodes and what their status is. And that does not require a ton of resources. Unless your cluster is like a million machines, but it's not. So we're fine. And over here are the worker nodes. The instance role is it's called the core nodes in EMR. And usually we want to use D-type instances here. And as we discussed earlier, the difference between a D-type instance and a not D-type instance is that a D-type instance has local SSD storage available to it. These non-D-type instances, they only have EBS storage available to it, and an EBS volume is not strictly guaranteed to be on the same machine. So it could be networked, but we don't know. So the latency in an EBS volume tends to be much, and the read and write speed on an EBS volume tends to be much lower than that of a local SSD. So we always want D-type instances. And the other reason we want D-type instances so we can have, local SSD is if we're caching a bunch of stuff, a bunch of tables or whichever in memory, and we run out of memory to cache those tables, we don't want the system to just die. Instead, we would rather just have it spill that data to disk instead. It's like, oh, I'm out of memory. I'm just going to put the rest on local disk instead. Make sense? Okay. Now, I was trying to decide before I assigned this on whether or not I would make you submit a script to start EMR yourself, but the problem is I can't really run those from my account because it requires all of this other account-specific stuff in there, like the security groups that I've created for, my AWS account. So this is what we have to do here. If I think of an easier way for me to run your code and for you not to have to specify all this stuff, then I'll have you guys submit scripts where you start the EMR tester too. But for now, it's just the thing. You also need to supply links to the instance profile and the service role that you normally use. And this is the same as, when you start an EMR cluster using the AWS console, right? Like when you start a cluster using the console, is this running? No, okay. Clone in the CLI. Oh, this one has steps. No, let's clone an interactive meeting. Okay. So you need to specify, your service role and your instance profile, and you have to do the same thing over here. So that's what that looks like. And the last thing that is completely unique to running EMR this way is you need to upload your code to S3, and then you need to give EMR a reference to where your code is so it can find it and run it. Now, I actually hate the way it does this. This is stupid. So what it does is it needs to create your entry point file, which is the file that first starts running your code. So it's basically like your main method in a different language. And then the rest of the code lives in a zip file. This is so weird. I do not like this. And if it turns out we only need the zip file, then I will update the project spec. Because this is dumb. But it works. So in order to actually create something like this, in order to actually run this code, first of all, I need to change this script to actually write dot mode. And then see if I can get this right on the first try. OS dot. What did I say the environment variable was again? This thing. Okay, is my syntax right? Oh, can I make this bigger? Yeah. My syntax right? I'm gonna ask ChatGPT if it's right. Because this is gonna take 5 minutes to try again if I get it wrong. And that's annoying. Okay, that gives us what we want. All right. So if that's all we have, then we can probably work on submitting it. Okay. So this is what's in the zip file. Literally, the entry point is just importing this. So, well, it doesn't import the zip file. It imports code that's in the zip file. And Python is kind of strange because you don't actually like need a main method. You can just write the code and it will run. It's the scripting language. So when you run this import, it should just run the code in this file. So that's the idea. Let's see if it blows up. Okay. Nope. Wait, this is in the examples. Okay, so first what we need to do, I was messing with this earlier, so we're just going to remove. So first, we need to create a zip file with everything in it except our entry point. Yay. Okay, so we're just going to recursively zip this entire directory, and we're going to call it we.zip. And we are going to exclude explicitly the entry point file. And that creates our willy.zip file. Oh joy. So now the entry point file hasn't changed, but I'm still going to upload it again anyway for demonstration purposes. So then what we need to do is we need to copy our code for both the entry point and the willy.zip file into a really? All right. So where I want this thing to go is I want it to go in this code directory in here. Oh, wow. We have even more technical difficulties. Okay. And it's going to go here. Let's watch that work. All right. So we just uploaded it and we should see the last modified change, which we did. Okay. And so now we just need to do the same thing for the willy.zip file. Okay. So now we have both. If it loads sometime today. There we go. Right, so now we have both of our files in there, and when we have our script to start the EMR cluster, we're referencing both of these when we submit the Spark job. So let's run our script to start the EMR. All right, so the script ran and we didn't have any problems. So we should see a cluster starting to run up here. And that is very squished. Okay, it's done. All right, now let's take about 5 minutes before we actually get to see anything run. So where this code lives is it is in the steps tab. So as you can see, we submitted a step, and the step's name is My Cool Spark Program, which, as you'll notice, is what we named it over here. So this is the code. This step represents this code that's running. And if something goes wrong, then you can see the, you can actually put print statements in your code, and they will show up in the log files that will appear here when this code probably fails.
And in the email cluster between when it's done, when it's after it's done out, so that you could put this in the pipeline to do them. You use it right. You could run rid of them to the pipeline. And not have to sit there and wait for that to be done, spinning up and then run the program.
No. So it will automatically start running once the cluster is finished starting up.
Where to do that?
So right now, it's in the starting state. The cluster is in the starting state. And as soon as it gets into the state where it's ready to actually run code, EMR knows that it's supposed to run this step. So that's why the status is pending. So it's waiting until the cluster is fully bootstrapped and started up before it runs this code, because we put it in the steps. So this is what it looks like when you don't run EMR interactively and you run it as just a job. This is what it looks like. This is how our identity pipeline runs when the product is called Consumer Insights. It's public now. But this is how our identity pipeline runs, is we have a script that runs every month to submit a giant job to Spark, and it just appears as a single step in this list over here. And it lasts 12 hours, and then it's done. And then as soon as it's done, the cluster will kill itself, and that's it. Okay. You can also configure whether or not the cluster will kill itself after the step ends. So that way, if a step fails and you don't want to restart the EMR cluster, you can submit another step to the EMR cluster and try again. So this is what it's configured as over here. So we're keeping the job flow alive when there's no steps, and the action on failure is continue. So if the step fails, the cluster will continue running. So the action on failure can also be configured to terminate the cluster. So if this step fails, we're just going to kill the cluster. And if you want to retry it, you have to start another cluster. But right now it's continue. Questions?
Find an error in the script. And then change it right on my security. You have to change it up in multi-factor.
So I would recommend you have a script that takes care of building the zip file, uploading the entry point, and uploading the zip file all in one. That'll speed things up. Which is also why I recommend that you don't use this when you're in your like primary development cycle, because the development iterations for this are a lot slower than a Jupyter notebook. It's a lot slower to try new things in this setup than it is in a Jupyter notebook. So I would recommend interactively writing your code in the Jupyter notebook. That way you can react to failures quickly. And then once you're pretty sure you have everything nailed down, try it like this and make sure it works. Because this is how I'm going to actually run your code.
You have an example for this?
Oh, I'm going to upload this exact script with maybe a couple changes to make it easier to read right after class. Ooh. That was my knee slash ankle slash hip.
Oh, no.
Mm-hmm. Oh, there we go. It's running. All right, let's see what happened. Wait, it worked? I can't believe that worked. First try. Let's actually see the log file before I start celebrating. Yeah, it takes a few minutes. Any questions in the meantime? From the peanut gallery over Zoom? Wow,
I'm writing.
that's fine.
I guess usually. Because we're writing to update policy. Do I have to have new data? You know, data them like and stuff.
What are the alternative things that you're thinking about? Oh, um, you you can theoretically write a dictionary to Parquet, but you can't use PySpark to do it. PySpark operates on data frames. When you write your files to S3 and you call .write.mode.parquet and you supply the path to it, um, you're doing that for a data frame. And so Spark operates on data frames, and that's the data structure it knows how to read. There's nothing stopping you from like using a separate library to create a Parquet file and then write that to S3 yourself, but you'd have to do it that way. Either that or change the dictionary into a data frame and then write it to Parquet. I mean, I don't know. Are you still doing that thing where you have to transfer stuff from between Livy and your local session? Ugh.
I have, I mean, it's only this thing. I have a dictionary, I mean, I don't know. We have a list of the single elements. And the single element is the dictionary, and you only have the foods, you have the dictionary inside. So I don't know how to type it, you might try to put that into Google phone. I don't know if there's anything to Google that, you know, store the dictionary in the column.
You can, but the types have to be consistent. So every row in a data frame needs to have exactly the same types. So every column needs to have the same type, and every row needs to have the same type for the same column. You can, it's possible. So you can store practically any Python structure in a data frame as long as the structure matches between instances, if that makes sense. So if your dictionary has 1,000 key value pairs, as long as the key types are the same and as long as the value types are all the same, then that's fine. And they have to be the same nested all the way down. So if the key types are all strings, great. If the key types are some strings and some integers, it's not going to work. You have to kind of combine them, or what's the word I'm looking for? Convert. Jeez. You have to convert them all into the same type.
When I can make my keys, column pennies, column use. On my values, except that one of those values is another dictionary. Even a B.
So Spark has a map type that allows you to like create a hash table as a column type from an arbitrary key type to an arbitrary value type. So that's what a dictionary maps to in terms of Spark types.
Find that column and
You can define the column as a map whose key is a string or whatever, and the value is itself another map. So you can nest the types all the way down. The type system for Spark is surprisingly powerful in spite of the fact that it doesn't actually have that many types in it. Oh, okay. So log files are available, and let's see what happened in standard error. Oh, nothing happened. Perfect. Okay, now let's see if it actually wrote to the output that it was supposed to write to. Where was it supposed to write to? I forgot. Supposed to, it's just Willy results. Okay, let's see if we can see. Oh, look at that. I can't believe that worked. Okay, perfect. It worked on the first try.
because how would you verify this? How do you check it? Like a reading back in?
I don't, yeah, we got to read them back in. So let's do that. So we're going to kill this cluster right here, and we will start an interactive cluster.
I could use that instead.
I mean, maybe we could, but I would rather separate my clusters between the ones that run interactively and the ones that do not. Because a lot of the time they'll use different configurations. What are you doing? That. Okay. And because this is interactive, we don't need this extra config option up here. And we'll start that. Oh, I started Jupyter Notebook in the wrong place. Yay. Where did I start it? It's up here. That's better. Okay. So now what we need is we need to actually SSH into this cluster. It's not available yet. Never mind. And I copy and paste commands from the guide that I wrote, so I know it's good. Unless you guys are having a problem with it, then it's not good, and we need to fix it. Is anybody having a problem with this? I think I already asked that, and everyone said it was perfect, and that was the end of the conversation. Mm. That took its sweet time. Did I start this before it's actually ready? I did, didn't I? We're gonna see if that produces any problems. Well, the Spark server started. We're gonna see if starting the Spark Connect server before this thing was actually ready is gonna cause any problems. That'll be interesting. See, look at all sorts of cool stuff in this class, even the ones that I don't intend. Great. Do you want to talk about anything while we're waiting for this?
I'm gonna take them the best we got.
Yeah.
Back to the CLI stuff.
Hmm.
I was trying to follow along and list from the data source we provided. And I definitely don't have access to those. But just like other S3 buckets I do have access to that I haven't seen CLI.
Okay.
Right.
So you're talking like the commons directory
Yeah.
is something you can't see when you list the buckets, or you can't list anything from the commons.
I think I can't see anything from the columns.
So yeah, try and list stuff that's in the commons bucket. And even though it doesn't show up when you list the buckets out, you might still be able to list the contents in the bucket.
I get access to mine.
Okay. I'm gonna have to talk to people about that because that means you don't have access to it. Okay.
I have access to a bucket with an Intel driver installer in my warehouse main on it.
What?
Oh, okay. In that case, do this.
Oh. Interesting. Okay. They must have been. Okay. All right. I will fix that problem. Thank you for trying that out immediately. Honestly, wait. You have access to that bucket. You have access to that bucket. I don't have access to that bucket. That is not one of my buckets. Oh, that's hilarious. So I didn't make that bucket, but you all have access to it. That's so funny. Did I delete the bucket or something? I think I did. I think I deleted the bucket, but for some reason it's still visible to you, even though I delete what the okay, we're gonna have to have a conversation, but that's not gonna happen today. Jeez, that's funny. Okay, let's connect to this thing now. Hmm? Oh, yeah. I keep forgetting that. No, I can't do that. That is not a thing that exists. Let's see what this looks like. Oh, something broke. Spark gRPC connection. No file system for Scheme SD. Oh, jeez. Okay, well, it must not have loaded properly. So then what we have to do is we probably have to kill the application and then restart it. So we can, and the scheduler for this thing is yarn. So we can look at yarn, applications, list, yarn application list, and it lists, it doesn't have any? That's interesting. Oh, because I started the Spark Connect server before this thing was ready, so it might not even started the session. So then we have to kill the actual server. Spark. It's probably this monstrosity. Yeah. Okay, we still don't have anything, which is good. Let's try and restart that. We can wait for a few seconds and see if the yarn application actually starts. And if it doesn't, then I screwed it up and I have to start a new cluster. And if I have to do that, then we're probably just going to end class right there because there's not enough time. Well, we don't have a yarn application running, which is unfortunate. Let's look at the UI. Let's see what we have here. There's nothing here. Oh, wait, yarn driver endpoint. So it looks like it registered. Maybe. Ah, there we go. Okay, here it is. All right, so let's redo the Spark connection. Whoa, buddy. Hey, hang in there. We only got 5 more minutes. You can barf all you want. 7 minutes from now. There we go. It's running properly now. 6 or 7 times honored. Apparently, that's a word. Usurps. All right. Well, it looks like the word count works, which is good. So we're taking, these are the results that we got from running the non-interactive EMR step, and we can load the results from that into our interactive EMR Spark session. So everything's good. Are there any more questions about how this stuff works? Yay.
Okay, so you do all of this, and now you put this into your interactive zone. Now you're looking this, now we're looking this in well, except probably it's not self-ness use. It's probably not 6 or 7 times often. I mean, somehow it's the outright space that you do when some maybe it's on.
Well, my theory is that maybe there were dashes in there. So instead of spaces, maybe there were dashes.
So at this point, let's say you were doing small boxes. So this point you do that like happens in many parts. And then is this the actual notebook that you turn into Python script? What you call? You have to look in as the notebook.
Is this the notebook that I turned into a Python? It's just, No, it's not the exact same, but we could still look at the original data set and see like dot filter. Um, I forget what the actual iceberg um are like. Okay. So then we can do that is wrong. F dot column value dot r like. And then we can see if it contains the word seven. And that should get us pretty close to where we need to go. UFO person, what am I missing? This is 6 or 7. Oh, okay. Oh, truthfully equals false. That's what we need. Let's look more specifically. Oh, there we go. They're all dashes. So what we did was we replaced the non-letter characters with empty strings instead of spaces. And so that kind of concatenated them all together. So this is an example of how we can check because this looks wrong, but given what our code actually did, this result makes sense. Whether or not we want the code to do that is another question, but it did what we asked it to do. So that's fine. Anything else? This is fun, right? Zoom link, you all good? Okay, then. I guess we're done. See ya.